Section 2.7, example 10, solving an absolute value inequality. Solve x minus, or the absolute value of x minus 1 less than or equal to 3. All right, so there's two things I want to talk about. What we're going to look at, I know the book doesn't really state it in this example, but we're going to look at less than or equal to, but we're also going to look at greater than or equal to. All right, less than or equal to, what we're looking at is a very concise value of numbers, because the absolute value, if we throw a really, really big number in there, let's say absolute value of 1,000, less than or equal to 3, there are plenty of values that are going to be less or opposite. So if we look at the opposite way, so 1,000, there are going to be plenty of values where we have the inside part greater than or equal to some value that we have out here. So if we have that, we have way more solutions in our number line. So think of like your number line from like negative infinity up to infinity. We have way more solutions that we could find. So we're going to have values over here, an empty spot here, and values over here with greater than or equal to. Here with less than or equal to, especially because we have the absolute value. The absolute value is going to get rid of any negative numbers. So we're going to have twice as many solutions, the left side of the equation, or left side of the spectrum, and the right side of the spectrum. So this one here, we have a more concise set of values. So for this one, what we could do is have it all under one absolute value, or one equation, one of those three-part equations. So from here, what we could say is that like drop the absolute value, x minus 1 is less than or equal to 3, but we also need the negative version of this, right? We could draw this over here, -3, so just multiplying this by -1 and adding it over to the left side. So -3 is less than or equal to x minus 1 less than or equal to 3. So it kind of looks like the same version here. We just throw a negative value over here and keep the signs going in the same direction. So we have the smaller version here, continue here, and the larger version over here. From here, we're just going to solve as normal. So getting the middle part to our middle variable to be by itself. So the only thing we have to do here is add 1 to all three parts. So -3 plus 1 is going to be a -2, less than or equal to x, less than or equal to 4. So here, this is our solution set. In set notation, we could draw our number line just to see where we are. So closed circles for these. -2 is less than or equal to x. So x is going to be numbers bigger than -2. So we could draw a little arrow pointing this way. And on the right side, x is less than or equal to +4. So numbers smaller than +4. So it looks like it's going to be all of these values right here that make up our solution set. So in interval notation, we go from -1 up to 4. Closed circles tells us that we have brackets for these two parts. And there we go. That's our solution, this solution in interval notation. And now what we would have to do if it were the opposite, if it were the absolute value of x minus 1 less than or equal to, or not less than, opposite sign, so greater than or equal to 3. Remember, there are way more possibilities for these numbers to be really, really, really big and also have an absolute value greater than or equal to 3. So because of that, we're going to separate it into two parts because we have two ends of the real number set to look out for. So we have x minus 1 is greater than or equal to 3. We also have to look at the opposite side, x minus 1, multiplying it by a -1, so -3, and us looking at the opposite side. So switching the sign and switching the sign. Switching the sign and switching the sign. And from here, we're solving these two individually. So this left part plus 1, x is equal to 4. Oh, x is greater than or equal to 4. Over here, plus 1, x is less than or equal to -2. And throwing this on a number line just to see exactly where these values are. X is greater than 4, so numbers bigger than +4. Close circle because it's greater than or equal to. And over on that side, and this second part, x is less than or equal to -2. Close circle, and numbers smaller than -2. So here is where we're going to have two sets brought together. So starting off with the leftmost value, it's going to be this part here. So from -infinity up to right here, -2. Closed circle tells us bracket. Union, that's supposed to be union. Next value is going to be this one. So 4, bracket 4. That's funny. Bracket 4 all the way up to infinity. And there we go. That's our solution set for this made up problem up here. If you have any questions, please feel free to ask. Otherwise, bye.